Hey everyone, welcome back to another Rust stream, couple days in a row. So it should be a lot of fun. Let's see here. Okay, audio is looking good. Sometimes I have a stream like pre-flight checklist, and I occasionally will forget to turn my phantom power on my mic or similar. So it's always a bit of an issue. Let's go ahead and open up Spotify here really quick. Make sure that's muted. Adjust that. Yeah, how's everybody doing today? Hope everybody's having a nice Thursday. Nice little way to wind down your week, I suppose. Gonna keep streaming today. I might do another one tomorrow, and then next week I'm gonna be out of town, so hard to tell for sure. But that being said, happy to stream when I can. I'm enjoying working on this project, sharing my knowledge. So yeah, having a lot of fun. I think at this point, probably the goal for today is to clean this up a little bit. Basically, I want to clean this up to the point where I can write up a little something and share it on that. I believe the Rust subreddit would be a good place to start, and then probably write up a little blog as well at some point. So that would be the goal, I suppose. Let's see here. Oops. Super loud. There we go. Okay. All right, yeah, let's get going. So this morning I was working on a little branch here. Basically, I'm trying to make it so it's easier to construct the server in the common case. So for example, I suspect that 99% of users of this are going to be passing in a handle to a device for an export. So for example, like a block device like your dev SDA or similar, or a file disk image sort of thing. So what I did is I created this new API called devices file. This might become some kind of like from implementation. I'm not totally sure yet, but basically it says that given a disk image path or similar, this will open up the file, read the metadata, so things like the file length, the permissions, etc., and actually unwrap that into this devices structure you can pass right to the server. So yeah, did that this morning. So yeah, we call the metadata, we check and make sure it's a regular file, so you can't export like a socket or a directory. We see if it's read-only or not, add that as part of the annotation here, and then we produce a function here which will open up the file. Me, be waiting for the Reddit post, trying to read the code, waiting for the blog post, not understanding the code or blog, crying in the corner. Yeah, I really think that for me, my experience with Rust has been, it's one of those languages you kind of have to read a book to understand. I read, let's see here, so the Rust programming language, O'Reilly. I read this a couple years ago. Yeah, there's a second edition now, actually, it looks like. This is kind of what gave me perhaps the knowledge I needed to get started. Oh, programming Rust. Sorry. The Rust programming language is the no starch one, the official one. I actually have not read that yet. I've got a copy. I have not read it. But I read this, and this really explained a lot of the concepts to me. I do also have a copy of Rust for Rustaceans, which I have just started, but I am not quite there yet. And I guess this is more of like an intermediate level book. So my plan is to read this one next, pretty much, and then kind of figure out what I can learn from that. But of course, for me, I tend to learn a good amount from a book, like kind of the basics, but I really have to like play with something to understand. So I did not understand, like, for example, use of like generics and trait bounds and etc. before I started this project, and I think it kind of just took me some time to figure that out, Yeah, so basically where I was at this morning is I was working on this a little bit. We're going to be tweaking this for a while, basically trying to polish up the API. But in the meantime, I think I broke the tests, so we're going to try and fix those. Actually, cargo watch test. Yep. Let's see here. So we have to fix up everything that use the exports type because I'm trying to slide this into just devices. Let's see here. Devices new, export new. And I guess I can pass this a function. For this particular test, we don't ever want to open the export, so I can pass a function here that probably always panics would be a good way to do that. Like, that's kind of my tendency in Go. So for example, we have a boxed closure, which takes a path name, which we ignore, and then panic, should never open device. Something along those lines, I think, would work fine. Let's see here. Arc new, exports new. Expected. What did I miss? So we have the return value, we have the box, we have the arc, the devices, semicolon, expected type. Oh, yeah, 2 colons. That'll do it. So in this particular case, this test, we never want to actually open the handle to the device, so we're going to panic if this function ever gets called, which is fine. Now we keep fixing the other ones. So test connection line 55. Let's see here. Undeclared type exports. Oh, right. So we're in a situation here where I'm trying to get rid of a type I don't want. I guess we just compare this one export. So we're going to make a copy of this ultimately. Let export equals this is the export we got. The export we want is going to be want or just export, I believe. Unexpected export received by client. This is probably going to be use after move. I imagine I've got to make a copy of it. Export cannot be dereferenced, right? Type is cannot infer the type parameter d. Oh, right. So now we're in a situation too where the handshake now has a type parameter. Shoot. So we have to give this some kind of type here because the devices type takes a generic, which is a read, write, seek. So I have to give this some sort of like synthetic type. So I guess perhaps something like an arc of devices of maybe like IO cursor. I guess would make sense. So like a cursor over a slice of bytes. Does that work? The trait IO write is not implemented for cursor because the cursor has to be mutable, doesn't it? The trait seek. Yeah, so we ran into this problem yesterday. We actually have to create a cursor here. The signature of an IO cursor that can actually successfully read over bytes like this is it mutable? I forget. So IO write is not implemented for, but it is implemented. Oh, it's the vector, not the cursor has to be mutable. The vector underlying it has to be mutable. So, or the slice underneath it. Okay. So in order to properly implement read, write, and seek with a cursor, and a cursor you can kind of think just like a view over a slice of bytes. A cursor is a type that can read, write, and seek over a slice of bytes. The bytes have to be mutable for you to write to them, because otherwise, if it's immutable, the cursor only implements read and seek. But we need read, write, and seek here. Although in this particular case, this will always panic. So it's just we're basically fixing the type here, I suppose. So connection line 79, we got rid of. So same sort of thing. We got rid of the exports type before. Yeah, I wanted the test to go, didn't I? Did we get this test working before? I don't think we did. Well, actually, no, we did. It's just that yesterday where we left off, the type would block forever. The server would, and I undid that for now. So similar issue. We have to specify the type of the device we're returning. So, because this can no longer be devices, this has to be exports. So an arc over the devices, I believe, is what we have to have. And devices has to, again, have a generic type. So similar kind of situation to before, where we're going to have probably something like this. So foobar, let's see. Or for this test, we do actually open the export. Okay, so yeah, we're going to allocate just a single meg of memory. it's going to be a cursor again. So we return a boxed cursor over a vector. So we have a vector of U8s, which are bytes. And then we have it the size of 1 MB byte. Okay. Cursor, box. And now the type can be inferred, so I don't have to specify the type on this one, which is good. Cannot be formatted. We can't apply equals to devices. Right. Well, we don't want to apply it to the devices. We want to do the same thing as before, where we have a single export that we get instead of a group of exports. So the export we've got, unexpected, export received by client. Oh, right. So this MB-byte constant here is a U64, but in order to use it as an argument to vec, or for the vec size, it has to be a U size, which is the size of a pointer. So that should be okay. The cursor, oh, so we need the OK variant because this can never return an error. Yep, and now we're ending up in the situation I mentioned before where we have use after move. So we have to clone our exports. So we clone it. Making a quick copy of it, no big deal. The client no longer needs a handle to this arc. We can actually possibly remove the arc. Arc being an atomic reference counter, basically, so you can share something. You can share references to something across multiple threads. Okay, so the test passed now. That's good. I think that if we... So this exports type only gets passed into... Yeah, so the arc now can go away, I believe. We will create the exports directly in here, I think. And then we can get rid of the arc, I believe, as well, because this is only going to be accessible from this single thread. Perform a handshake with exports. Move occurs because export does not implement copy. It gets moved. Oh yeah, it gets moved into the context of the closure. So, so let export equals export clone. I'm trying to move it. Okay, let's try this. Server export. Give it a new name. Yeah, okay. So we can remove the arc now, which is good. We're going to do the same thing for the test down below, because we are no longer sharing the entire device's structure between the tests. But we still have server export equals export.clone. And then this list of exports gets moved into here again. And this takes the server export directly, because we're making a copy and then we are moving, we're moving the copy into here. And now we no longer need the arc either, which is good. Okay. So test pass, that's good. What else can we clean up here? So I think probably this type was called devices because originally I had export, which is a single device you can, or a single metadata about an export, and then I had exports, which is a slice of them basically, more or less, and then now I have the devices type. So I think probably I could name devices exports, or yeah, I could name devices exports, I suppose, or I could leave it as devices, I guess, because it's a collection of devices together. So let's rename this to devices. That search and rename did not work. Interesting. Wonder why. So let's do the same sort of thing here. Let devices. Handshake over the devices. The mutable device equals... Oh, that's right. Yes, we did this yesterday. So we have the function to open the device and then begin transmitting on it. So We choose an export, and then we choose to get, yeah, so probably the way I want to do this is like so. Let mutable device equals devices get export name. Private associated function. Well, I guess I might have to export this now because in order to make this API usable by other people, it might make more sense. Okay, let's go back to make this public. Returns the device handle for an export name for client use. But now, see, beforehand I had this expect in here. So now I guess this has to become an optional reference, because if we're going to make this for use by others as well, then we can't hold the same invariance as before, but we can move this invariant check. So we'll do that. Now we will do devices get expect. This is where you have the invariant violation sort of thing. Sorry, one sec. Maybe the export passes a hint, so it should be impossible to fail. So let's see here. Expect is basically an unwrap. It'll panic if this fails. So whatever the message was before, I actually forgot already. Sometimes instead of looking at like git diff or git history, it's easier just to like go back and look at the source code on GitHub, you know. Invariant, wrong file. No, it's in the server type, that's right. Variant, there we go. Name was never added to the devices map. Yep. Okay. So we unwrap, and then we have to call the closure. Expect returns a T. Okay. Okay, seek is not implemented for option. I thought this unwrapped the option actually. So we have an optional box. We call expect, which consumes it. And then we should have a result. Okay. That shouldn't produce a result. Okay, we're gonna do the trick here. So let mute device equals the call of this. So first we get the function let open equals an optional function where we unbox it, we unwrap it, and then we actually invoke it, which gives us a handle to the device, right? Still not okay. Why? Let's see here. Seek is not implemented for optional box. But this returns not an option anymore. This is now the device handle. So we call open with the export name, which should give us a device D. And then we pass the device directly. So I'm going to make these smaller really quick so I can read all the type soup. Excuse me. So it builds fine now. Oh, you know what? I may have been misreading that. No. Oh, just the tests are failing now. Oh, okay. I thought that I was misreading the stack trace. I thought that this was failing actually. So we control the list of exports. Should be impossible to fail to look up an export by name when using the server type. And then the name of the export is passed as a hint. And then once this device goes out of scope, the device is cleaned. The device handle is cleaned up. Yep. Okay. For an export by name for client use, if the device if the device exists. Barely usable. It sounds like a kinesis advantage. Yes, it is, actually. Yeah. Taryn added this yesterday, but yeah, kinesis advantage too. I'm excited for the Advantage 360 as well. I think that's going to be a cool keyboard. But for the time being, yeah, I just have the Advantage 2, but yeah, I love it. Definitely a great keyboard for sure. The device exists. If a device with the specified name exists. Cool. Has there been an announcement on the date for the 360? I haven't seen anything. Yeah, there was so they did like a pre-order thing, I think on like Kickstarter or Drop. They did like 500 units you could order, but no, I don't think that there's been like a general release announcement. I don't know. Good question, but I definitely am interested in one. I considered doing the pre-order as well, but I kind of wanted to wait to understand the differences between the models because they got the one that was the, let's see here. They had a model that was the USB model, like wired model, but it had like their proprietary firmware, but I guess the Bluetooth one had open firmware. So I definitely want the open source firmware, but I wanted to understand the differences and stuff. So that's something I have not looked at yet. But yeah, it should be pretty cool. I'm excited about that. Let's go fix all the tests really quick too. I'm gonna leave this small for a sec just so I can understand. Read is not implemented for optional box of dynamic function that takes a string slice that returns the result of a vector of, it's this whole thing. Definitely coming from Go, these error messages are harder, devices.get.expect. Let's see here. Device was not added to map. Device is not added. Let's see. Device handle was not found. Okay. So let open equal a boxed function, and then let mute device equals open export name as well. Expect failed to open device. Got to pass another reference or another slice. Okay. Is that everything? Let's fix all the tests. Sweet. All right, cool. So we managed to eliminate a type I didn't want, which is good. Yeah, so let's see here. We're at the point now where we have an export. You group them into this thing called devices, which can take either whatever handle you pass or possibly a file. We try and open the device for transmission. Seems like this works just fine. So cool. I think that I can probably commit this now. We've successfully removed the exports type, which is good. Or I guess we made it so it's unexported, if you will. Or I guess in Rust the term would be private. I'm thinking of Go parlance here. That lived under frame. So struct exports public within the crate. Okay. So this stores the default export and then a vector of additional exports, which can be non-default as well. Okay. So I will amend the previous work in progress commit. Let's see here. So this is handshake, or no, server. Make device replace exports. Public uses of exports. So now, did I fix the re-exports? Yes, I did. So server connection. Okay. So we're at the point now where I'm going to pull this back into the main branch. Go ahead and cherry pick this in. And then we can push that. And then we can delete the other branch. So exports work in progress. Cool. I actually did not run Clippy, so shit. Every time. Okay. So we got to fix this. It'll fail CI. So I need to remember to run Clippy on commit or something. Needless borrow. Line 165. So devices is already borrowed. Let's do some cleanup here too. So this now becomes devices. Git hooks, yeah. You know what's funny is I really have never even played with git hooks, to be honest with you. It's just something that has eluded me thus far. So, yeah. Devices from request, you pass the exports, handle directly. Okay. With metadata, expose metadata from devices, possible for the client to clear a server. Client is ready for data transmission. Yep. So now we also have, there's this lock thing here, and I guess I could potentially make locking optional, I suppose, if I wanted to, but that might make other things untidy. So hypothetically, hang on just a sec, I'm just looking at this. Okay, so server, fix Clippy, lint, okay. So now, I have this concept of like these locks here, but they're not necessarily required. I guess this is something that my server implements, but, well, probably makes sense to leave it alone. This is kind of an awkward API, isn't it? You pass a set of locks to the handshake, but that's because the server manages its own set of locks up here. So, because I need to be able to stop the handshake. I need to be able to return an error during the handshake, because what'll happen, let's see here. So we haven't run the server today. Let's do that. Actually, so I had some really interesting results running with larger block sizes. That's something I want to investigate next. I actually got some really serious speeds off of this thing, so we're going to play with that today, I think. You've written a small post on using git hooks for some of your Go code. It's basically a file with some bash commands, pre-hit commit. Nice, yeah, thanks. I will. I'll put that in my notes. I'll take a look at that. It's something that I definitely need to take a look at, you know. So, right. So if we run this in release mode, and then let's just copy and paste the command from here. And actually, it's testing with 4K block. Ooh, excuse me, 4K block sizes. So you see here now we have debug logging as well. I actually added the log crate and a simple logging thing here. So disk image, file export. Yep. All right, let's run a quick little IO test on this guy, or just a a read test, I suppose. 1.2 gigabytes per second. That's pretty good. I feel like, you know. I was actually playing with this too. So if I run a block size of 8K, what happens? 1.6, yeah, so that's pretty wild. I am curious what the kernel is sending. So first of all, we want to disconnect everything. Let's see here. So just disconnect all the devices. Yeah, I wanted to play with block sizes some more. So that is under the transmit connection, I believe. Offset length. So we want to show the length values, although there's going to be quite a few. So let's export from like a really small disk to start with. So allocate 1 megabyte or 1 megabyte. Small.image, something like that. Now we'll load small.image. So if we run this, we now have a tiny export. Yep, okay. So that works. So now I want to see what kind of frames we're getting here for the reads and writes. So that would be a read frame, because it's interesting. We do send the kernel a block size, or we send the block size to the client, but it seems like the kernel just kind of does whatever it wants. So I'm not really sure how that works. This is just going to be temporary. It's going to slow things down a bit, but I just want to share the value of the request. Yep. So see, look, the kernel is putting 131,072. So it seems like it's basically totally ignoring whatever it is that I specify. Although, hang on, if I specify a 4K block size, what happens? Yeah, it seems like these length values are still huge. Oh, you know what? I think, isn't the block size actually the minimal addressable unit of the, isn't it the minimal addressable unit? Because the kernel can choose to read more than one block, but the block size is the minimal unit you're willing to read, I think. I think this is a situation where we need to consult the nbd spec. So I've got that bookmarked over here. All right. So block size. So there are 3 block size constraints defined here. Server with block size constraints should advertise during handshake phase and must do so unless it's agreed. Block constraints from out of it means, let's see here. It's like a whole paragraph, man. Let's see. So we're talking the server perspective right now. This is something we're going to have to care about for the client eventually, but I want to start with just the server. So other than the default, should advertise the constraints during handshake phase via info block size. We do that. And it must do so unless it has agreed on block size constraints via... Oh, you know what? I don't think that the NBD client actually requests the block size at all. So we are advertising it, but the... All it's telling us actually... the only thing the client is requesting is info on the export itself. It is not actually asking for the block size data at all. So it's completely ignoring our requests. I think that's actually something we can tweak. So let's find out. I want to try a couple tests here. This is something I intended to dive into a little bit today. So say, for example, here, we go back to the NBD client call. We have the server running, and we have this export available, right? So there are some flags here. -B for block size. The default value for the block size is 512. So what happens if I pass a block size of like 4096 or something? I'm actually not sure what will happen here. That seemed to slow things down, possibly. Oh, you know what? It's logging, so this will also slow things down. So let's run without. I'm very curious here to understand what happens. So the client still doesn't bother to ask for block sizes. It just picks one. I'm not sure how this works, to be honest with you. Let's try this with something really small, like 512. Seems pretty quick. About something bigger. Failed to set up device. All right, let's give this another shot. So it failed to set up the device for some reason, and dmessage is not telling us anything, actually. Do we have mounted at all? We do not. That's weird. I just want to try this again. Now things are out of whack somehow, so we might still have a bug in here somewhere. Okay. So fresh setup. The client is sending us, I'm going to shrink this just for a sec. I'm sorry, I'll read it. The client is only asking for the export info still. It's not even bothering to send the block size option. How does it work then, I guess? I think we might be looking at man pages in a sec here. Let's see. So 4096 seems to work. Let's go ahead and clear out all the block devices really quick. All right, let's look at the man page for this. So you can connect to a server. Let's see here. Use a block size. The default is 1024. Oh, so the allowed values are limited. So if I pass 8192, it just doesn't matter. Might have to go back to the spec here to understand what's going on. All right, coffee's gone. Unix socket. I do want to test that at some point too. TLS is something I should look at as well. Let's see here. So we have things like the ports, swap device. That seems crazy. A network swap device. Yeah, so let's see here. Some servers can make optimizations such as opening files with O direct if they know that the client will obey a particular minimum block size. If the client issues an nbd opt-go with the block size information request, which it's not, it must abide by the block size. Yeah, it's just choosing not to send that for some reason. So the server should support a minimum default block size of 1, preferred of 4096, and a maximum of unlimited. A client constraining. Reads and writes to a maximum block size of 2 to 25. Servers should not refuse clients that do not request sizing information. The default sizes. Yeah, so the thing is here, like, I want the client to send us the size constraints because I want to be able to do potentially some of these optimizations and such, but I don't understand what the deal is, I suppose. Let's see here. The smallest addressable length and alignment within the export. Yep. Power of 2. Maybe as small as 1 for an export backed by a regular file, which is the case for us. More typical for an export backed by a block device, 5, 12, and 4096. Yeah, because the block device would have like the sectors. So for regular files here, I can pull. For regular files, the minimum could be as small as 1, but for a block device, it would have to be as small as like 5, 12, or 4096. Yeah, let's see here. The advertised export size should be an integer multiple of that block size. Otherwise, the client would be unable to access the... Right, okay. So the minimum size at which aligned requests will have efficient I/O, the preferred block size, read, modify, write, must be a power of 2, at least as large as the maximum block size. So everything we've done so far has been testing with just like files on the disk. Like, you know, basically we're faking it. But what would be interesting, I guess, is if I were to, you know, test this on my server or something with like an extra hard drive, like literally expose the block device directly. That could be pretty interesting. I don't know if I have an extra hard drive at the moment, but excuse to buy new ones, you know. Actually, you know what? I think I have some old like 4 terabytes sitting around. I could probably try and expose over this. That would be interesting for sure. Let's see here. must be a power of 2 at least as large as the maximum of the minimum block size in 2 to the 9. Larger values are more typical. So I guess we should probably go with the defaults for now. Like we should set up the minimum of 1, the preferred of 4096, and the maximum of effectively unlimited. Should be at least 2 to the 20 if the export is that large. The server may advertise. Hang on. The client must ensure that the offset and length are integer multiples of any advertised minimum, but it should use the preferred block size where possible. Yep. So the server should report an e-inval error if the client's request is not aligned to the advertised minimum block size boundary or it's larger than the maximum. Okay, so yeah, I think that I kind of have the TLDR here. I apologize. I don't really want to read a paragraph on stream, you know, but I think I understand now. I think I understand where we're at, basically. So what I'm going to do is I have had a couple of to-dos in the code for a while, basically to decouple the block sizes. So I'm going to start doing that. So, excuse me. We have the export structure lives in here somewhere. Yes. And right now we advertise just what is the preferred block size, but in our case, the minimum, preferred, and maximum are all identical. However, we can advertise 3 different values, and thus we should do so. So I think what we're going to do here is do that, actually. So block size, can I make an anonymous struct here? Would that be minimum is a U32 pub struct. Does this work in Rust? I forget. Nope. Doesn't seem so. Pub block size is a struct. Does that work? Does not seem so. Okay. So we could either make a struct here or we could make like a tuple struct. Like I was thinking basically the first step I suppose would be this, which is the minimum, the maximum, and the preferred all together. I suppose that is perhaps not the most friendly, but I guess if you're working at this layer, you might be expected to understand this in the first place. So default values as specified, as recommended by the nbd protocol specification for regular files. Notably for block devices, these values should be tweaked. The minimum and preferred values should likely be modified. Cool. So we're gonna have a minimum of 1, a maximum or an intermediate of. Can you do this in Rust? Yeah, you can. You can have big numbers like this, so that's kind of cool. I forgot. So the maximum is the max uint32. So no inherent limit. Okay. I feel like I should give this like a constant name or something. Seems like it would be better. It's infinite. U32. So the max infinite value. The largest possible block size. Okay. So now we will have the ability to tweak this. So probably what makes sense is to be able to tweak all 3 block sizes at once. So right now I've currently had these coupled to a single value, but it probably makes sense to modify the entire tuple at once. Sets non-default block sizes for the export. The arguments are the minimum, preferred, and maximum block size. The tuple arguments are the minimum, preferred, maximum block size, respectively. So 3 U32s. Block size is, we'll make this plural too. Okay, what is going on? Weird instrumental, oh, okay, cool. Right, yeah, so continuing on. So now we have to modify the code that had previously hard-coded this in 3 different places to accept different values. So 496, also first. Block size is blank, blank, blank. We can do this actually. So min, pref, max, min, pref, max. We can actually destructure the self block sizes. There we go. Yep, that makes things a little tidier. Block sizes, min. Oh man, so every time I tweak this string, I have to go fix the tests, which is not great. So you'll understand my pain shortly. I've done this a few times now, and it's not my favorite thing, but what are you gonna do? All right, so continuing on. Handshake frame, line 500, minimum preferred max. So can you loop over a tuple, I wonder? Does that work? Self block sizes. Does that work? I wonder. Export block sizes. So you can into iter. Does that work? Method not found. So tuple into an iterator. Hang on. So Rust tuple into iterator. Possible to iterate over a tuple. Tup.iter. The type of each element in a tuple can be different, so you can't iterate over them. I see. However, an array is exactly equivalent to a tuple with all elements of the same type. Yeah, you know, maybe I should make this an array then instead of a tuple. Maybe that makes more sense. An array of 3. So U32, 3. Let's see here. Tuple arguments. The array values are the minimum preferred. U32, 3. Yeah, I guess that makes sense. I was just thinking tuple because I've used them more often. Arrays are kind of inflexible, but I guess that's okay. So can we destructure the array as well? Yes, we can. Sweet. Cool. I like it, Rust. I like it. Line 986. Expose min-max as well. Yep. You know what? This was a tuple as well. This needs to be an array now as well. Three block sizes, U32, 3. Okay. Cargo watch. All right, so now block size contains an array that we destructure manually. Actually, no, we don't want to destructure the array because we have the block sizes Block sizes equals block sizes. Okay. Cool. Suppose I should probably rename this as well to block sizes for consistency. 1191 is block sizes, yeah. So min pref max. Okay. Now we've got, let's see here. Convert the identifier to, okay, so handshake frame 29, it just wants us to name the constant better. So it renames it according to the things. Largest possible block size. Max infinite, okay. Cool, so it seems to pass now. Cargo test, got to break all the tests, I'm sure, yeah. So this is where we get ourselves into a bit of a pickle because I had previously modified the string among other things. So 1846. This is not a realistic export. Consider updating. Yeah, so all the block sizes are going to be 0. That's the array literal syntax, right? Oh, 0U32, not U8. Block size. I'm going to modify the name of that as well. So now the test should start failing because I changed the string. Yep. Okay. Unfortunate. Unfortunate. So it's going to be 1, 40, 96, and then whatever the big value is, which is the infinite. So, shit. Oh, no. Oh, no, bro. This is not great. You're going to understand the pain of these tests. All right. Ready? Excuse me. So now what I have to do is I have to modify this string and then modify the length. So the length of this was 44, but now it's longer. So we're going to do one of these at a time. I think we did this on stream yesterday too, and this was something I continue to struggle with, you know, but cargo test. Yeah, we want to run just the one test for now. Server options go full. Go full. Okay. So the defaults, we are going to advertise, instead of 4096 now, we have different values for each one of these. So we got to look at the byte dump and figure out where it changed, which is, you know, about as fun as you might expect. 1403, okay. So the minimum now is 1. The preferred is going to be 4096, and then we got all max. So, okay. So that should fix that one, I believe. Yes. Okay. Continuing onward. All kinds of fun here, huh? Cargo test. This individual test, right? Server options list full. We run into the same situation where now we have this string, which used to be 56 bytes, but is now longer. Let's see. So instead of being 56 bytes, the length changed to 70 bytes, it looks like. And then the block size is going to be 1, 4096, and then maximum of... shoot, so what's the max uint32 in decimal? So let's see here. 2 to the 32 is that? Is that correct? That's ugly if so. Not quite. I don't think. So 1, 4096, and then this is way too long. So, why did I do this to myself? Let's just print, I guess. So if we run this really quick, already in use. Oh, okay. Yeah, so we get this value here. So all kinds of great, huh? So 14096 blank, yeah. That seems like a not very helpful error message or whatever, so I'm gonna want to fix that too, probably. Or not very helpful message at that point because it's so long. So I was right. Did I get the length wrong? I thought it said 70 bytes beforehand, but we have to look at the dump again. Again, I'm sorry this is small. It's impossible to read these on a bigger. It's just, well, I guess it's not impossible. This is a little more doable, but it's still hard. 54, 108, 5832. So we are 1 byte different here somewhere. 57, 32, 115, 1, okay, 101, 115, 58. There's a 115 in here. Did I mess up the formatting maybe? If I go back to the frame type, the minimum deferred, the max, block size. Oh, you know what I did, I think? Block size is that why? Size, the block sizes are blank slash blank slash blank. So this is still not quite right. Probably got the string length wrong again or something. So I thought the length was 70, but it's probably 71 now because I added a byte if I had to guess. No, it's not. So now we're back to reading the byte dump. Yeah. Starting to think perhaps this style of test for these strings is a little inflexible and annoying. So you end up in this situation where you're just looking through byte dumps trying to figure out what's different. Again, I find myself missing some of the libraries we have in Go for stuff like this, like the diffing library. 56 to 70, so... Oh, shoot. I was modifying the name length. Uh-oh. I think I was modifying the wrong length field, so I think the name is going to be 3. Right? Yeah, okay. So the issue here for these list responses is that the name of the export, in this case, this byte string right here, is treated separately than this arbitrary kind of metadata. So everything beyond the length of the name gets treated as metadata. So, yep. Okay, that's 2 tests fixed. What else can we do? We have the server options round trip, which is also another big ugly. So I'm gonna make this smaller again. Server options round trip. This is not a realistic export. Block size is 1 4096, and then the big 14096 slash. Those are some nice looking errors. Yeah, not my favorite. It's because you end up with these big byte dumps. I think probably it is in my best interest to make these more comprehensible at this point. Like, instead of dumping the bytes for these big tests, like just dump the final structures or something and see what's different about those. But I'm not quite there yet either. Hang on just a sec. My playlist ran out. There we go. Back at it. You wonder if you can make assert equal print debugs. Yeah, I think it can. I believe, if I were to format it as such, but maybe there are probably better assertion libraries I'm just not aware of yet, if I had to guess. But cargo test, server options round trip. Okay. So probably the same issue as before. We have to fix the length to 70, right? So 1, 4096, and then the big ugly. If I had to guess, anyway. If that's all it takes, I'll be surprised. Yeah, okay. So this also has the other block sizes, which is going to be a minimum of 1, a preferred of this, and then a maximum of infinite, right? Okay, I think we're closer probably, but yeah, you know, let's see if we can fix this. Let's see if we can fix this this macro to make it easier to understand the round trip tests here. So let's just see what it is that it prints out at the end. Would be more useful, most likely. So now all the tests pass. That's concerning. Oh no. That is not that is not what I was hoping for. Which means that somehow it's parsing correctly, I think. Yeah, that's not it's not right though. I feel like there's something subtly wrong with this. So I'm gonna go back to dumping the bytes. So it looks like we got probably 1 extra byte somewhere in this dump. So isn't that great? 1258. Three, 2. Ah, you know, it's the length again. I saw a 58 and I saw a 70, and those values come to mind. So we have to change the length of the string. Let's see. Is it, shoot, was it this? No. It's kind of funny how you work on this for a little bit and you get to the point where you can kind of stare at the byte dumps and find something wrong. So this is supposed to be 70? I honestly have forgotten at this point. Three, 2. 3, 12, 16, 3, 2, 58, 70. How many strings are there? That's when you get help. Yeah. Yeah, I'm definitely making myself suffer a little bit for this one, aren't I? I feel like it's got to be this length string still, but what was it before? I guess let's diff it. So 44 to 70, 56 to 70. It was 44, but now it's even longer. So how about I iterate per byte in the test and print out the diffs with the index? Yeah, that would definitely be a smarter way to go about this. I'm just not sure if I want to invest the time, although this has definitely bit me a few times now, and perhaps it would be reasonable to make that time investment, you know. So it was 44 before, it's 70 now, 56 before. So it was 12 larger for some reason, right? So 44, 56. Why is it so much shorter? What did I change? Is it because I was only dumping the 1 block size before? Excuse me. Just gonna try some random values here really quick. $58, 66. So it seems like 58 is the value we do expect here. 58, 3, 102. Oh, you know what it is? It's the stupid S here, block sizes. Because I changed the damn string too. Yep. Yeah. I think it'd probably be a good idea to make test helpers for this though. Like take a string literal, dump out its length in bytes, and inject that into this field, because like this is getting obnoxious, you know, every time I change this thing. So yeah, let's so really quick, let's stage what we have, and then I want to probably give that a shot. Block sizes is an array of 3 elements. Because every time I change this string a little bit, I have to fix this diff, and it sucks. So let's see here. So handshake frame, support, differing, min, pref, max, block sizes. Yeah. All right, so I have, for example, the export string. So I could take the, don't I have the metadata? There's like a method on it that can create metadata or something. So what the heck is this? Sorry, Spotify doing the thing here. This is weird. Okay. Anyway, yeah, I think probably it would make sense to like hard code this string, like, because I keep writing this out. Block sizes, I've got it in 4 places, right? So bar. One of them is read only though, one's not. I don't know. I'll leave it alone for now. I want to get back to what I was working on beforehand. So yeah, we are at the point now where we can run this in release mode, and we should be able to show, yeah, different block sizes. So if the client asks for them, then nbd clients-l, but why exactly would it not? Why exactly would it not? I need to get some water. I'll be back in just a sec. Something else we're going to need to do actually is we got to make sure we clamp this down so that if the maximum block size is larger than the device, then we can't actually perform an I/O, because the it wouldn't be able to perform an I/O successfully, I don't think. So we'd have to clamp this down, I believe. Yeah, so I'll be back in just a sec. One moment. Where's my? There we go. Okay, let's give this another shot. So, I still want to understand like what it takes to make the client use our block sizes, but I guess for the time being, we can just try and make the server a little smarter in that regard, perhaps. So first of all, what I just mentioned before I walked away for a moment is the server devices here. This needs to be able to clamp the block sizes, if possible, to the maximum size of the device. So let's see here. Yeah, thanks, Google, whatever. It may be something other than power 2, but it must be either an integer multiple of the minimum block size or that for no inherent limit. Should be at least 2 to the 20 if the export is that large. The server may advertise a maximum block size that is larger than the export size. The client must treat the export size as the effective maximum block size. Ah, I see. So the server actually doesn't have to clamp the value, which I guess is reasonable. It's up to the client to have that kind of smarts. Yeah. So the block size is the addressable amount of the device. So if I were to try and expose a disk directly with this, then things would get a little more interesting. Or if we try like direct IO too, that would be another interesting one. If we try direct IO though, then we actually need to enforce the block boundaries and such. So how would that work? If I were to expose a file, if I expose like a loop device or something, I wonder how that would, no, that wouldn't work, I don't think. Because I don't think I have any, I think I just have my SSD in this computer. I don't think I have any other, yeah. The server's got a few drives, but yeah, I kind of want to expose a device directly now. It'd be interesting. So let's see here. Linux virtual block device. Yeah, loop device. Loop setup. LO setup. Yeah. So we could create a device backed by an image and then see what happens if we were to, yeah, maybe try something like direct IO. But I'm just curious now. So let's see. Does the open options type have anything? Does open options have anything to do with like direct IO mode? So rest open options. Let's go ahead and close the rest of these. Well, we'll close this. So append, create, yeah, all the cross-platform ones, I suppose. So the extensions for Unix, for WASI, file mode, custom flags. Ah, here we go. So this is where we could pass, oh, direct probably if we want to. I'm curious. I guess the thing is I'd rather not rely on like sort of hacks that aren't cross-platform either, but yeah. So where we're at so far, I want to open up the documentation for this again and just take a look and see kind of what interfaces we're exposing, keep tidying things up, and then, yeah, we can consider more optimizations and such perhaps, but build that. Yep, came up in the wrong browser like usual. So we have the devices type. Constructs devices using path to open a local file as the default export, which makes sense. I could probably make it so you could chain multiple calls to this and open multiple files for different exports would also make sense. So say, for example, I want to have the big and the small export just for different tests. So we have, yeah, my SSD is only 900 gigs. It's like a terabyte-ish. So I want to make just a bigger image here. So let's try like 512 and then try some really big reads maybe. Although I guess it would be reading zeros for a lot of it, so I wouldn't even have to perform disk IO, right? So now we have this big image. Let's see here. Okay, cargo run, release. Something else I wanted to do today, maybe a little bit, is test around with FIO, like kind of see what kind of performance we're actually getting. But I think the problem is, though, is that like there might be optimization. So for example, we allocated what is effectively an empty file. So even though it has 512 gigs of space, it didn't actually write all of that out. So there may be optimizations in play here that we are not aware of. Guess we'll see. So let's try this with a block size of pretty freaking big. I think this can do meg, right? 1 meg. And I guess this will take a little bit because it's still a lot bigger than the typical exports we've been using. Because before we did 4 gigs, now we're doing 512. So maybe I should have done a smaller one to start with, but I'm just curious like how much IO we can push through this thing, you know. And at a 1 meg block size, it should be pretty quick, I would think, but I don't know. Still a lot of reads, you know. Something else that would be interesting about this is actually we can start exposing support for different commands for optimizations, things like trimming or trim, writing zeros, stuff like that too. I'm curious like how, for example, that would work in Rust, because we can have like, you know, extension traits basically that we can bring into scope, and that's something I'm not familiar with yet. I haven't really worked with, so I'm not exactly sure how that would all fit together. But yeah, this is taking a little bit. I guess we'll see what happens. I wonder if I hung it, honestly. You know, I'm running this kind of YOLO, seat in my pants sort of thing. I suppose we could also do what I had talked about earlier and start writing up like a Reddit post for how we want to, you know, I want to share what I've learned so far, I guess. I think that would be cool, but I don't know for sure. I guess at what point do you decide like you want to share your work with others? You know, it's like I've been sharing on stream, I've got the repo online, but at this point, like I'm kind of seeking critical feedback from people who know more about Rust than I do. So I think that would be useful for me, but I don't have anybody to really talk to about that at the moment because I'm just not part of the Rust community as much. So I feel like Reddit is a good place for that. And this is still running. It's a big one. So last I knew, this thing can move multiple gigabytes per second of disk IO. So I'm curious what we did here. Seems like it's still stuck. The Rust Reddit is pretty good. Yeah, that's what I figure. Like I've seen a bunch of posts on there, so I feel like that's probably going to be a good place to seek and solicit feedback and such. You think some of the more niche communities are also really nice, like the Tokyo Discord? Oh, good to know. Okay. Yeah, this is Tokyo actually. Yeah, so that's good to know. We had some questions yesterday. There were some folks asking me if like, you know, some of the stuff I'm doing is inherently tied to Tokyo, and I was like, I don't think so, because it's all just futures. So, for example, if you choose not to use the server type, which is doing Tokyo spawns, then you could use probably whatever runtime you want, I would think. But frankly, I'm not really sure, you know. This is taking a long time. So let's try and it's probably very hung. Ah, sweet. Let's disconnect all the devices again. Let's allocate a smaller big file. So allocate, let's try 32 gigs. The Rust runtime, or the runtime generic async implementations are a very common thing in Rust. Yeah, for sure. One day, maybe. What's up, Taryn? How you doing? Let's try this again with the big image on just a smaller disk, I suppose. Because that thing was large, 32 gigs. Or the previous one was 512. 32 is still big, but it should be a lot quicker, I would think, still. Unless this is like totally wedged, in which case, I guess we'll find out. Doing all right? Yeah, good to hear. Yeah, we're hanging out here, screwing around. Okay, 1.4 gigs. Hey, welcome, Tarun. Nice to see you here. Thanks for stopping by. Let's try smaller blocks again, because it seems like the smaller ones work pretty well. 1.4 gigabytes per second. This is faster on my laptop. I guess maybe the Western Digital SN850 is that much better than the Corsair Force MP600. I guess I don't know, because this was one of the first PCIe 4 SSDs, and also I don't think I had been running trim for a long time, so I set up all the FS trim stuff. Speaking of which, 1.4 gigs. Okay. Probably get that going. I'm not sure if this will mess up the stream or not, but let's go ahead and run a trim here in the background, because we just allocated that big file, and just see what happens. Right, so, okay. Metadata querying, yeah, we don't have that done yet. So I think that the stuff we support so far, so the baseline implementation, no TLS, yep, fixed new style, yes. Info and Go with the nbd info export response, yep, we support that. We do support abort, we support list, rewrite and disconnect. So yeah, I think we've reached the baseline implementation. For maximum interop constraints through block size. If we desire interoperability with older implementations, we should implement the opt export name message. I do not, actually, but I have both of these, so cool. Linux kernel does not implement structure replies. Interesting. Yeah, so we've already implemented quite a bit, I suppose. 780 gigs trimmed, yeah. Clean up those discard those unused blocks. Block status query request. There is writing zeros, there's cache, there's trim. Yeah, so trim is an interesting thing. I guess we could potentially, I wonder what it would look like to issue like a trim ioctl, like how's that look? So Linux trim, I'm guessing it's an ioctl if I had to guess, but fi trim ioctl, aha. Linux fi trim. Good old Elixir, how does this work? So we can trim a file range. Interesting. This is where things could get pretty interesting, because like we can start implementing optimizations for things like SSDs versus hard drives. Oh, you know, speaking of which, actually something else I wanted to do is there are flags you can use to describe like the shape of the media. So for example, if it's like rotational, it can modify the algorithms that like Linux will use to query it. But this could be fun, doing some ioctling. some ioctaling with like trim and such. That could be definitely fun. So we might have to look at that. In the meantime, let's keep using the default image. Let's go look at some more flags. So direct IO would also be something I do want to play with at some point, but I don't have any optimizations yet. Let's see here. So we have reads. I probably need to take a look at this. Reads, writes, disconnects, we do that. Flush, we do that. Trim, not yet. Cache, not yet. Write zeros. The cache is a command. That's an interesting one. You can tell the server, you can tell the client, or the client can tell the server that's going to keep accessing the same offset of data, so we could potentially like store it in memory. But I have no idea how much that would be useful, or if you'd be better than like, the file system cache or similar. Or like the device cache. So no holes, don't fragment, fast zero. Where was the... This is all negotiation stuff. What was I just mentioning? Rotational. Yeah. So characteristics of a rotational medium. So for example, if I were to expose a hard drive over this, that would be interesting. Trim, hard drive, so SSD optimizations, hard drive optimizations. This is interesting too, the multiple connections. This is something I would like to look at. So server does not cache or is shared among all connections to a given device. So the effects of flush and FUA must be visible across all connections. But clients can multiplex their commands over more than one connection to the single export. So in that particular case, I think I would need to modify my locking mechanism, but basically if I were to gate IOs to the drive or to the file, or make sure I only lock on writes, you could read multiple sections concurrently like on an SSD, which would be pretty interesting. So it's pretty cool to see how this like specification has evolved over time. But yeah, let's start with this rotational flag. That's something that we can do pretty easily. Rotational. It lives under handshake frames. Send F. Yeah, here we go. Rotational. nbd flag. Rotational, right? I thought so, at least. Okay. I thought that we matched on this at some point. Maybe not. So the default flags will be things that the server supports: flags, flush, FUA, forced unit access, which is another caching on write, basically. So for rotational media, we would need to specify that in the export constructor. So that would be something that we would add another option for. So marks this export as read-only. Marks this export as being backed by rotational media such as a conventional hard disk drive. Such as a conventional hard drive, I feel like. This can be used as a hint for clients to modify their access patterns. Because, for example, if I was going to test this, this is a bit like you writing your 9p implementation. Yeah, it's a similar sort of thing. I find this pretty interesting, and I think that Rust is a good language for this because, like, I wanted to create kind of like a data plane protocol sort of thing, and I'm having a lot of fun doing it. Rotational mute self. Transmission flags, rotational, right? Cool. This can be used as a hint for clients to optimize their access patterns. Cool. Cargo watch change now? Were these tests failing before? I don't feel like that would have changed the tests. Interesting, okay. I'm actually not sure how that would change things, but... Because it's not a default flag, right? I mean... Unexpected bytes. Server options, info, minimal. The test export does not have... It does have all the bits set. No, that's not what I want. I probably just want the defaults. Right? So when we create this, for example, we added a new flag, so the test changed. Okay, but I just want the defaults here. The defaults being... Oh, yeah, I was setting all the flags before, but I don't think that's actually what I want. So transmission, flags, low, yeah. Because if I set every flag, then we have to update the tests every single time, right? Because the test export just uses the defaults. Oh, it does set read only. Well, shit. Defaults plus read only, I think. True. Does this not return? It does not. Okay, so let's ORM then. So ORed with read only. I suspect this will fix things, but yeah, okay. Turns out containing the low bits of test exports, transmission flags. Defaults plus read only. Don't bother setting every new flag. Cool. Test again. Okay, sweet. Taryn, is your 9P, is that written in Go or is that Rust too? I forget actually. But yeah, it's definitely interesting. I like working on these kinds of problems because like you can really deal with like, you know, performance and just sort of more interesting problem space. It is Go. Okay, cool. Cool. I wonder what it would take to expose trim. That would be pretty interesting. I kind of want to find out. The thing is, once I start doing that, though, is that like this becomes like a very Linux-specific crate, which I don't really understand the implications of quite yet. So you haven't updated it in a while. Gotcha. Handshake frame, expose, add transmission, flags, rotational. Okay, cool. So now we can advertise exports that are using rotational media. Pretty silly, huh? I feel like this should be able to like max hard drives based on the numbers I'm seeing, but I guess the problem is that like if I start testing this over a network, I'm going to be crippled by the 1 gigabit connection between like this and my server, but I could install a hard drive in my desktop just for testing. That would be interesting, just for fun, you know, like and have it basically owned by this this daemon. Well, shit. Now I kind of want to do that, but I can't exactly, you know, stop stream, turn my desktop off, and you know, but maybe later today. Could be fun. I definitely need to find some things like humanize these bytes a little better. It kind of stinks at the moment, but rotational, fixed unit access. What else do we? I'm trying to think of like what else I wanted to look at. So I suppose we can keep working on the client. That could be interesting because right now we have to the point where we can perform the handshake in user space and do this, but we don't actually hand off to the kernel client. We could hand off to the kernel client with this, but because yesterday we made it so that we can actually create a client IO connection and hand over for the transmission phase, but we can't actually perform reads or writes yet. That is something that we could work on. That could be interesting, you know. But also, like I said, I kind of want to gather feedback from like Reddit and such. Maybe handshake in user space sounds like a dub band name. Yeah, totally, for sure. How many to-dos do I have in here? Probably tons, you know? Yeah. Oh, I'm getting stuff from like the Target as well. Sounds like ska. Yeah. Pretty funny. Yeah, you know, I feel pretty good about what we've done so far. Maybe it is time to like at least like publish a basic crate or something and just start getting API feedback. I think would be interesting. You know, actually, I should probably fix this because I have like the log and such. I can make the client and server into separate modules, or excuse me, separate crates, I suppose. So cargo new bin server, or I guess MDL nbd server. Okay. So this would actually go into here, into this cargo toml. So how does this work exactly? If we want to start moving, let's see here, source main. Yes, this goes into the main for the server, I suppose. And then the server file goes away. So I've actually never created like a multi-crate workspace before or something, so I'm not sure exactly how this works. Could not read server bin rs. Cargo toml. Oh, that's right. So I guess this no longer becomes part of the workspace, right? Failed to parse manifest, default run target not found. Yeah. Okay, hang on. So this works, but now if we go to the server cargo build, can't find MDL nbd. Yeah, so this would need to be a dependency, which is going to be the local crate, right? So how exactly does that work? You add a dependency. Let's see here. MDL nbd server. Rust 2021 nbd-rs nbd server. Rust server. So this is, let's see here. So and asynchronous Rust. Synchronous Rust server implementation of the network block device protocol. So a demo Rust, asynchronous Rust server implementation of the network block device protocol. Synchronous Rust server. Server for the network block device protocol. Cool. A demo asynchronous Rust server for the network block device protocol. That seems reasonable to me. So MDL nbd equals, you can specify a local crate, right? Cargo local crate, something like that. Specifying dependencies, crates IO, other registries, from Git repositories, from a path, which is going to be ... right? Something like that. Cargo build. Because I don't want to pull in, for example, like logging dependencies into my crate, you know? Sweet, okay. So we have to pull in Tokyo. So we have to pull in Tokyo. We have to pull in the standard error log. Did you import colors? I think I turned the color off because I found it to be annoying, but I don't understand. I'm not sure exactly what you're asking quite yet either. So I guess follow up with your question. Extern crate Tokyo. Okay, so if I pull the copy of Tokyo, I'll use the same version I have above. Hey, that works. Cargo run. Okay. Cool. So now we have a separate crate, I suppose, that depends on just Tokyo and standard error log, and I guess the nbd crate too. But sweet. That was a joke. Oh shoot! The what was it? The JavaScript thing recently? Yeah, I forgot. Cargo run. Pretty goofy, man. Okay, so what happens if I... Can I do this? MDL nbd server, which lives under source bin main. Does this work? Or is this gonna, because it's a different workspace? Spin MBL nbd server. Source main. Oh, because the standard error log crate isn't in here. Ah, okay. Let's see here. So Rust multiple crates. So if I want to have multiple, hang on a sec. Format. Okay. I think this will be okay, but I'll remove the binaries and then I'll put both of these in separate crates too. MDL nbd server. So now we have a new binary here. And I guess in theory, I wouldn't mind having both MDL nbd demo maybe? Let's call it that. Let's see here. So demo asynchronous Rust client and server applications for the network device block device protocol. Cool. All right. So now we make instead of bin, now we make server rs cd to the demo, go run. Source lib, source main, our lib section or bin section. Ah, that's right. So I needed the bin section. So, which I just deleted, but yeah, I can copy and paste. This lives under source server rs, right? And then the default run target, I have already forgotten the syntax for that as well. Oops. Let's see here. So nbd-rs md layer. Is this indexed by Google yet? Not quite. Stealing stuff off GitHub, always. There we go, default run. Client, okay. Move the client. Cargo build, cargo run bin client. I thought I created. nbd client, right? Okay, so I think this works now. So cargo run release. Except we need to move the disk image, I believe, as well, actually. Move the images. Run, and then cargo run bin client. Yep. Sweet. Okay. They work. That's good. So demo asynchronous Rust client and server applications for the network block device protocol. Sweet. Fix the ordering here because it'll drive me nuts otherwise. Tokyo. Yeah. Okay. So now we've removed the, we managed to remove this from we managed to remove the dependencies specifically for the server, like for logging and such. So that's good. Cargo run, let's see here. How does this work? No. Cargo build, cargo, just tidy up all the files and stuff, make sure things are good to go. And then we can commit this again with the new lock file and such too. Oh shoot, I don't want to add the, I don't want to add the image, the disk image files, start image. Okay, that should be fine then. Is that really trying to add the, oh, it's adding everything under target, right? Let's see here. So I want to unstage all of these. Oops. What a mess, right? Git restore staged MDL nbd demo. Okay. So we separated out the logging and such. So MDL nbd demo, new package, split out client and server. Doesn't cargo init create a get ignore with a target in it? You don't remember for a library, but it does for the bin option. Yeah, so the thing is, it wasn't at the root of the Git repo. So I have an inner Git repo here. Or I have an inner folder here now. So I think that was the problem. So the target folder had to be ignored for this as well, I believe. Suppose perhaps I should make this configurable too. Let's see here. Making progress. A couple hours into the stream here. So we got the client, we got the server, we pull in just the crates we need, and we use, let's see here. We've got a logger, we've got Tokyo, which we need for the client and the server. Or I guess just the server. I don't think the client relies on Tokyo at all, does it? The client just uses futures though, so. We'll use this Tokyo types actually, I suppose. So, excuse me. I know that in the examples there you can actually create like a here I'll just pull it up. Sorry. So Tokyo mini Redis. What they've actually done here too is they created this blocking client. So basically, you create an API around this where you build a Tokyo runtime for the current thread. You run the future and then you just return it. This is kind of interesting, and I wonder if it's worth doing this, but I have no idea if this is actually idiomatic or not, you know. So, anyway, yeah, things are in pretty good shape here, I think. Probably at a point now where I could start sharing, you know, things a little bit. So that's all pushed. I haven't run Clippy actually. Is that going to tell me anything about the new crates? No. Okay, cool. So something like somebody make cargo build everything recursively, like build every. Oh, workspace. Cargo build -- workspace. Aha. What happens if I run that? Oh. Cargo clean. So now does this compile everything? Cargo workspace. I want to make sure I understand this. So create a workspace. Ah, I see. Workspace members. So if we do this, apologize for flying by the seat of my pants here a little bit, but workspace members equals nbd demo. Cargo build. Workspace. Aha, cool. Cargo run. Now can this run binaries from the workspace too? I dropped you a snack. Thanks. I appreciate it. I am kind of hungry. Let's see here. So that seems to work, but how do you run something from... Let's build the workspace by running cargo build cargo run -p -p demo. Aha! Interesting. So cargo run -p, huh? So if I move the demo images again back to here, I see. Okay, that's not so bad, I suppose. I wonder if I can specify a default package to run from. Probably. Cargo test -p. So cargo workspaces. You can have the members. Oh, the workspace has one target directory. Cargo clean. Does that mean this is... So now if I cargo build this again... Oh, I see. So I think it is, now it is using the target directory. So it's because I created an unrelated... Oh, but now it pulls into the lock file. Although I guess that's fine because it's only going to build what it needs. Because you're not necessarily pulling in the entire workspace. So, huh. You know, I'm not sure. So let's see here. A binary crate and a library crate. As your project develops, the library crate continues to get bigger. You must split up your package further. Cargo offers workspaces. Okay. Same cargo lock and output directory. Create the cargo toml and configure the entire workspace. You think in most places you've seen the top level workspace package is naked? Oh, okay. So cargo lock, cargo toml, adder, lock toml, add one, add two. Ah, yeah. Interesting. That's new to me. So I guess I would want to put the crate, you know, the effects and everything. Yeah, no big deal. Yeah, I guess I would prefer to do this in the idiomatic way if possible, but all crates using the same version of all dependencies. Yep, makes sense. Okay, let's see if we can reorganize this, I suppose. So maybe we move the source and the tests to. So right now, if I run cargo test, okay. Let's see. Right, so cargo new lib mdl nbd. Two packages named mdl nbd in this workspace. Yeah. Okay, so I will move my cargo toml into the nbd package. I will move all my source files into the nbd package. So I have the cargo lock, I've got the root files and such, and I have an empty source directory now, right? Nope. So I want to move source into mdl nbd. Oh, I see. nbd source. Okay, so now we've got a cargo toml for the crate, the library crate. We've got the source files for it. We've got two top level, we got the target, we've got tests, which should probably also go to here. Yeah. Source tests. Okay. Could not find a cargo toml because I wiped it, didn't I? Yeah. Okay, so we just, at the top level here, we'll have a cargo toml with just the workspace statement, right? You need a cargo toml on the root with workspace config. Yep. Sorry, I wasn't reading my chat for a sec here, but I see. Multiple workspace roots found. I see. Okay, fix that, fix that. Failed to get MDL, nbd. Oh, because I changed the path, didn't I? So I have to modify. Okay. I'm going to close this because Rust Analyzer is going to freak out for a little bit. Cool. Okay. I think that did it. Thank you for the help, Oscar Allen. I really appreciate that. This is all new to me again. So, oh, sweet. So now if I do run, it pulls up the server. Awesome. That's great. That's perfect. So the default run target still is the server. Awesome. That's sweet. Cargo test. Awesome. And then if I run something like Clippy, does that go over a file too? It would seem so. Okay. Reorganize into workspace. Reorganize into proper workspace. Cool. Good deal. Cargo build, cargo test, and then cargo run. Everything works as I would expect. Dash bin nbd demo nbd clients. Does that work? Yes, it does. Awesome. All right, sweet. So that looks good to me. Yeah. I wasn't exactly sure how that all fit together. I think I just seen a couple of examples in like open source projects, and I kind of wanted to give it a shot myself. But yeah, that seems like that works. So we learned how to create a multi-crate workspace here. Good deal. So now block size equals, let's try like a 1 meg block size or something ridiculous. Let's see. $1.5 gigabytes per second. Oh, that's pretty cool. Useful snippets for testing. Cargo run -s release. Run the server in release mode with disk.image. Allocate a task disk image to export. Fallocate, so -l. So let's just test these instructions really quick, because if I want to share this to Reddit or something, so -l, yeah, let's say 4 gigs again. Cool. That's so awesome. I love it. Run the server in release mode and export that disk image in another terminal. Use Linux's nbd client. Use the Linux kernel nbd another terminal, negotiate a connection in user space, hand it off to the Linux kernel nbd client, run a dd read test into dev null, then disconnect from all nbd devices. Yeah, pretty cool. Oh, it's amazing. Enable the crates debug logs via standard error. Just that image as export. I'm way too amused by this, like just the fact that it all kind of works and is pretty fast, like coming from a Go background. This application doesn't do much yet. This application doesn't do much yet since many of the features. Crab goes burr. NVIDIA client features are incomplete. It just tests that we can successfully negotiate a connection with the default export and then disconnect from I/O. Cool. Yeah, I think it's time to publish this crate. I think I would like to do that. That'd be nice. Just make sure all the dependencies are latest versions really quick. I've got this helper here. Okay. Yeah, I feel good enough about this so far. I think that I've done about probably as much as I can. Let's open the docs here really quick. Just want to see what they look like. Wrong window as expected. Cool. Rust client and server implementation of the network block device protocol. Yeah. Seems pretty cool. I feel fairly happy with where we're at. How do you publish? I wonder how publishing a workspace goes. If I want to publish like the cargo workspace, hang on a sec. Publishing a crate. Yeah. I'm going to want to add examples too, for sure. Cargo doc -- open. That's what I'm using right now. Panics, errors, safety. Documentation comments as tests. Yeah, doc tests are great too. Commenting the contained items. Yep. Pub views. Yep, I'm doing that because my API internally is all broken up, but I'm doing that. I've got my cargo login already. I have a package, publish. I've got, see, version, name, version, edition, description, license, name, version, edition, authors. I tried to do as much as I could, I suppose. Cargo, publish, yeah. So if I wanted to publish this now, I could. Let's see. nbd demo. More comments about testing. Okay. I feel like I need some examples to like make this like look good or something, but I don't know. I don't know. the client, the server. Something else actually I thought about earlier. I could potentially make this from file. No, but then yeah, I was thinking about making this an implementation of from, but the problem is with that is that I need to be able to open the file repeatedly. And if I have an open handle to it and convert it, I can't do that. So, that's okay. I feel pretty good about this. Well, you know what, gang? It's been a couple of hours. I am getting kind of hungry and stuff, I guess. But I feel like we made some pretty good progress today. I might go screw around and see if I can get a hard drive plugged in or something, just for testing this further. I think that would be pretty interesting. Yeah, so I think I'm probably going to call it a stream. It's been about 2 hours and 15-ish minutes. Let's see what's going on really quick. All right, cool. Yeah, this has been a ton of fun. Thank you all for hanging out. I really appreciate it. And I hope to see you next time, possibly tomorrow, I think. I guess we'll see. All right, take care now. See ya.